So I'm going to breeze over how to find that above information, the measures of center and the measure of spread in the calculator, because the lesson that we will do on Wednesday really goes into that further. But just so we can look at this real quick, I'm going to use data from the next pages of notes and follow the steps. So at the very bottom where it says box plot and then there's some numbers, I'm going to type these numbers into my calculator. So in order to enter numerical data into our calculator, we've done this before. We're going to click stat and we can click 1, or you can just click enter. And then I'm going to arrow over to whichever list I want to use. I want to use L1 and I am going to put in my data. So once I have my data entered, we're going to calculate single variable statistics. So when we were using calculator before, we were typing in L1 and L2 and seeing the relationship between those two variables. In this case, we're just working with one variable. So we're going to click stat. We're going to arrow over to calc. And we're going to press 1 because we want one variable statistics. And then I'm going to click enter. And this gives me my one variable statistics. So I'm given the mean. Remember, we use that little X bar. I'll write that, which is 6.375. I'm also given the standard deviation, which we'll use. We've got here. We've got the total number of data points. We have the minimum value. We have quartile 1. We have the median. We have the third quartile, and we've got the maximum. So we've got a lot of information here. So what I'm going to do is write my standard deviation, 1.67. I'm going to write my total number of data points, which I could figure out just by counting the total. I'm going to write my minimum, which is 3, Q1, and this will mean a little bit more later on in this video. The median, 6.5. But this saves me a lot of time. I don't have to order the numbers and do all these calculations by hand because they can be done for me pretty quickly in my calculator. And then I put the steps in there. So notice how it gave me my standard deviation. I have the steps in here for our mean absolute deviation, but we don't need to go through and calculate all of that together. We are going to look at visual representations of single variable data. So we've got some quick vocabulary. The first vocab, looking at it, is using dot plots. So we're going to talk about how to create your own dot plot and then what the 3 different shapes of it mean. So graphs provide a visual representation of data. We're used to that. Just by looking at a graph, you can quickly understand the spread and the center of a data set. So our first way of representing it right here is each data value is represented by a dot. So what I can do is go through and count how many data values each number has. So I'm going to just start with this first number. I have 3 6s, so at 6 on my number line, I'm going to put 3 dots. So we just had our, data. Each point equals 1 dot, and you put it exactly where it's located. So the way you can describe a data set, looking at this, it looks pretty symmetric. The data pretty much remains constant throughout. There's kind of an outlier here at 7 and one at 0. It's not skewed to one side or the other. So data that's shaped like this, we call asymmetric. So asymmetric data, the mean is close to what the median is. So when I have asymmetric data, our mean and median are pretty similar, and it doesn't matter which measure of center we use. It matters when we have skewed data. So if it's skewed to the right, that means my mean is going to be skewed to be larger than my median, because what's happening here is a majority of the data is on the left, but because of these outlying greater values, the mean becomes skewed to the right. So whatever direction the tail is located is the direction it is skewed. So over here we have data skewed to the left. And when it's skewed to the left, that means our mean is going to be smaller than our median, because we've got these points that kind of fall, much lower than the majority of the data points. So that's a dot plot. Another way of representing data in a similar way is a histogram. So dot plots and histograms show the frequency of a data value, and it's easy to see repeated values and the overall spread. So it was easy to identify which way it was skewed. The only time you would use a histogram rather than a dot plot is when you're working with more continuous data. So it was easy to create a dot plot here because they were all just whole numbers, and the numbers didn't get less than 0 or greater than 7. That made it pretty easy to create the dot plot. But for example, if I'm given this data where I've got tons of numbers that are different from each other, then it's better to use a histogram. So the height of the rectangle above a value or range of values, so like I'm counting by tens here, corresponds to the number of data values with that value. So this is better for a larger data set or continuous data. That's when it's better than a dot plot. So sorry, this doesn't look very good. This is a 29. But what we're gonna do is just place each value in a certain category. So as I'm looking at these, I'm just gonna quickly write down the numbers in the bin. That's what we're calling it, putting quotes on bin, because each of these is a little bin. So from 20 to 29, that's the range that 25 falls in. I'm just going in order so that I don't get mixed up. And you can do these on the calculator, and I have steps provided for you to do so, but even though it takes a little while to do these by hand, it is possible, and so it's good to know, what is happening behind the scenes in your calculator when it's giving you these numbers and these images. You kind of know what it means, and you can interpret the data. Okay, so I went through and used all my data points. They're all located in their bins. What I'm gonna do in black is I'm just gonna write those totals. So we've got 2, 4, 4, 1, 2, 3, 4, 5, 3, 1, 0, 1. So what's gonna happen is we're gonna use these values for each bin, each little range, and draw a rectangle. So I already have my frequency graph drawn out, and we're going to make the first bin, so from 20 to 30 is going to be 2 units tall. From 30 to 40, it'll be 4 units tall. From 40 to 50, it's also 4 units tall. From 50 to 60, we are 5 units tall. From 60 to 70, we are 3 units tall. From 70 to 80, we've got 1. 80 to 90, there's nothing. And then 90 to 91, 90 to 100, we've got 1. So this is kind of skewed to the right. Not super skewed because there's only a couple data values, but it has that shape, right? So I know that my mean will be probably closer to this greater range than my median. And that's just another way to easily look at the way data is laid out. So the last thing that we can use to represent data, the last graph we'll learn about, is the box and whisker plot. So when I was in school, we always called it the box and whisker plot. Now it's usually just referred to as the box plot. But it's named because we've got this box in the center and these 2 lines that go out to the sides, which we refer to as the whiskers. And a box plot shows the minimum, maximum, first quartile, third quartile, median, and median of the data set. So this is our general structure. We've got our minimum data value. In this range, we've got that bottom 25%, which we talked about when we were talking about the vocab. The inner quartile range, which is kind of our middle 50% of data, and then that top 25% of data. So a lot of times when we are looking at test scores and things like that, they'll use the box plot to show you where the distribution of scores is. Because you can tell that in this one that I've made, it's pretty evenly distributed. We've got maybe a little bit more above the median, a greater percentage of values, but not that much larger. So just like we did there, we can make a box plot by hand. So this is actually what we calculated on our calculator before. We got the median, standard deviation, the total number, the minimum, quartile 1, the median, quartile 3, and the maximum. So what I'm going to do is I am going to draw a little number line first. I know my minimum is 3, so I need to have 3, and my maximum is 9. So 4, 5, 6, 7, 8, 9. So I didn't need to go that far, but I did. 4, 5, 6, 7, 8, 9, 10, 11. But what I'm going to do now is create my box plot. I know that the ends of my whiskers are my minimum and my maximum, which we said were 3 and 9, which I can see in my data set, right? I know that quartile 1 ends at 5. I know the median is 6.5, so I just want to be kind of estimate where 6.5 is. And then quartile 3 is 8. And then I have my box plot. So when we have our box plot, when these are actually evenly spaced, you can see what portion of the data values fall in each quadrant, in each increment of 25. You can also find the inner quartile range by looking at the box. So this way of representing data is super important and useful.